I've been making these mallets for the last few years. It's two pieces of material that I join together with a joint that I make on the CNC machine. It's sort of a radial joint that comes out looking like little pegs in the end, holding the handle and the head of the mallet together. I've started to experiment a little more with gluing up pieces to make the head mostly, and sometimes the handle on the mallet. I've had a little bit of a problem tracking down big enough material to make the two pieces, as they need to be roughly 3.5 to 4 inches on a side to get to the size of mallet that I want to make. One avenue that I've taken up for finding wood to make the mallets out of is my friend Ben, who runs a sawmill outside of Salem, Oregon, Zena Forest Products. A few years ago, he got the contract to make the floor for the new airport renovation here in Portland. He's come up with a way to make a wood tile, basically, that could be glued down to the subfloor of a space, and you very quickly and easily make a very nice wood floor, and very durable wood floor. So he's hosted our old woodworking tool group get together for a few years. So about 2 years ago, Ben asked a few of his artist friends to make something out of the flooring pieces from the airport, as he was having a end of project party for the people who work at the sawmill. And he gave me a box of the sticks of white oak from the airport project. And my first thought was to try and make mallets out of it. And I think I made 5 mallets for that. They came out really nice, and it worked really well. And in fact, Ruben, Ben's brother, is building a German-style timber-framed structure as some shop space at the sawmill site. And he's been actually using one of my mallets that he got at this dinner party. I've sort of always thought I'd make the mallets well enough so that they could be used, but they would be so pretty that you wouldn't ever want to actually hit anything with them. But he's been actually using his mallet, and he says it's holding up very well. He says it's the nicest mallet he's ever used, which was also nice to hear. I thought I'd go over how the floor tiles at the airport are made as a quick aside. So he's got a bandsaw mill and mills up the logs that they grow on the property. The big thing that I really like about what Ben's doing at Zena Forest Products is that it feels like it's beyond sustainable. They're almost curating the forest. They're very careful about which trees they take out. They don't log with heavy equipment, so they don't crush the soil around the trees. They slab up the logs. The slabs are dried in on-site kilns, and they heat the kilns with the scrap wood that they get from doing the logging and the slabbing. At the sawmill, they have the rough machinery to get the slabs into more of lumber dimensions that can be taken to the space that makes the actual floor tiles. So they've got a facer, which is basically a big joiner with a gigantic feed on the top of it. And the feed is a series of spring-loaded spikes that push the board along over the joiner knives. Then the boards go into a planer, and they get dimensioned. Ben says he's got the planer dialed within 1/1000th of an inch from side to side. And it'll keep that dimension over time. You can run lots of wood through it, and it won't change. Then once it's been jointed and planed, there's a rip saw that cuts everything to the same width. At a separate facility, they have a little factory going where the lumber that's made at the sawmill comes in at one end. And I didn't time it, but it felt like it took maybe just a minute or maybe 2 minutes for the piece of lumber to become a floor tile, to go through this whole process. the bigger pieces of wood are fed onto a conveyor. That goes into an automatic crosscut saw that cuts off the ends, and it cuts the middle section into equally length sections. And the thing that's kind of fun to watch is there's a sorter just beyond the saw with a compressed air nozzle, and it sees which pieces are too long or too short, and it squirts them off the conveyor. Then the scariest machine in the shop, only because of the saw blade it has, the pieces run through a gang of circular saws that cut each of these pieces into strips. And this is what the saw blade looks like. So it cuts all of the strips in one quick pass. Then the pieces are put into a hopper. And I think this next section, the pieces are just aligned, so they're all parallel. Then the pieces are sorted, and this actually takes a person to actually look at each piece. And they're looking for knots or sapwood or cracks or discolored parts. For the airport, they wanted a very even color to the floor. So they were kind of picky about which sticks would make it. Once they're sorted, they're pushed together, and then they go into another machine that cuts a slot on the bottom, which is now the top, which is what that little twist was. And then into that slot is pressed a wire cable, and that wire cable holds all the pieces together. So there's no glue holding the tile together. It's just friction fit. And those are inspected as they're coming out, and then they're ready to go. They mostly make white oak, but they've also tried other hardwoods. So what Ben offered me was to take some of the sticks that get rejected, and maybe I could use those to make mallets. They had a whole dumpster full of them when I came down. I got a dumpster full of reject sticks, and Ben gave me a box of the nicer sticks that had passed inspection as well. And I got a lot of sticks. I brought them home and started sorting and finding that I could get a lot of usable ones, but there were a lot of unusable ones as well. And I did a small box worth of usable pieces and then decided this was just going to take way too long. And I just started shoveling them into boxes to get them inside. It's really fast to sort them, it's just there's so many sticks. I think I may even need to think of other projects I can do with these, because there's just so much. Then I've been sorting inside, which is a little easier. I can kind of listen to YouTube videos and sort sticks.
And now here I am, I'm using my Typon 3, which is my favorite glue, dry stock, especially with walnut. I'm getting some glue on those dominoes and banging them in.
The first idea I had was to make a herringbone pattern with the sticks, so that the end of the mallet was a little herringbone pattern, and the sticks would make up the head of the mallet. And it started out really slow, being super careful, and then it got a lot faster as I got better at doing this. So the idea with making these was I would glue two into an L shaped and clamp those together. And once I had a bunch of L's, I could stack those L's into sort of a little plane, and then those could be put together into the three-dimensional mass of the head of the mallet. I kind of had a shape that I made with the different L pieces, so I had something that was as close to round as I could get, and then I could use a pipe clamp to hold them all together while the glue set up. The problem with making this head this way was the final glue up was gluing all these L's together, and it meant gluing and clamping in two directions, sort of in 2D. So it was always a little stressful, wondering whether I was going to get every joint There's hundreds of little joints in that glue up that all need to be perfectly tight without any space. And for the most part, it worked. I did have, I think, one or maybe two that didn't quite work out. I tried one where I glued up the stacks of L's and let those dry and then tried to glue the stacks together, but they didn't fit well enough to give me a tight joint between the different stacks. What I had to do is glue all the L's all at once, get glue everywhere, and then just clamp it as hard as I could with the hose clamps and hope that everything was going to be okay. I think it is kind of the most fun pattern. It's just the hardest to make. Then I think early on I was cutting on the table saw to cut these to length. I ended up using the radial arm saw, which you'll see later. You can see the pattern that it makes in a mallet. And I think this one worked out okay. Then another idea I had was, why not just make a sort of standard brick pattern? I think this pattern is a stretcher course. So I glued up some flat panels, and this was a lot easier in the way of clamping, as I could glue a set of sticks together and then put a clamp over the entire system. And then I'd have a series of panels. And I cut those panels closer to the length they're going to be at this point, when they're not so thick. I sanded the faces of the panels on the disc sander. Then I could just glue all the panels up and get the mass of the mallet head. And you can see what the pattern looks like on a mallet. Then the other pattern I tried was sort of, I think, a parquet pattern. I'm not sure if that's what it's called. That's what I'm thinking of when I see this pattern, where I'd glue the pieces together in pairs, but they're parallel. So I can glue them all at once with glue in every other joint. Then I get a series of square sticks that I found were almost square. I think the width and thickness of the sticks isn't 2-to-1 like I thought it was, which also may be why the herringbone pattern was a little bit of a problem. So I would have to quickly rip down the width of the square pairs that I had made. But once I'd done that, I could glue the pairs together and get a panel, just like in the last example. Then those panels could be sanded and glued together to make the mass of the mallet head. It was still a lot of work gluing everything because every surface still needs glue, but it was a little less stressful as there were more steps in the glue up process where I could make things go together perfectly. And you can see the pattern on the end of the mallet. The sides of the mallet head look the same between the different patterns. It really doesn't matter. It's really just what the end looks like. Then I made some handles out of walnut. I did make a few mallets on this go around with solid pieces, and I made a few this way. And I had a few leftover handle blanks that were a whole bunch of different kinds of wood glued together. And those actually turned out really interesting. I may do that more and not be so afraid of making things out of pieces instead of trying to do monolithic parts. Then once I have the square, I can cut the lengths that I need. I think the handles are 7 inches and the heads are 5 inches. Keeps it easy. Some of the herringbone patterns I had to clean up a little bit, as I'd have parts sticking out so the hose clamp would work better, but then it made it less clampable at this stage when I'm putting it on the CNC machine. So I have this table clamp I made that holds the handle and the head vertical. And I can find the center. I'm not quite sure what I'm finding here. It doesn't look very accurate. The drawing file for the joint I have centered on the center of the joint. So I line up the 0, 0 of the CNC on the center of the piece, as it's a circle. So the center is sort of the best way to reference it, I think. I could flatten the top, which is super important because that's part of the joint as well. I think when I first did this years ago, I didn't even think to flatten the top, and I kept wondering why the joint wasn't going together. So It's like, oh yeah, I've got to make the top surface also part of the cut so that the fingers are exactly the same length on both the head and the handle. That cut pretty nicely. And doing one of the handles, basically the same, just walnut. I learned if I was doing a handle that was two pieces glued together to face the joint along the y-axis. It's just the way my drawing is. It puts the joint in the center of one of the fingers instead of along the edge of one of the fingers. And if it goes along the edge, then it ends up not quite being exactly at the edge. You get this tiny little sliver of wood. One of the many tiny little micro problems that you find doing these kinds of projects over and over and over and over again. And glue, I did this a whole bunch of times. This is one going together. Kind of think it'd be cool to have a press to really get this joint together. And then once it's pressed, then I can clamp it. I did have one in this batch where I didn't get it all the way together, and there's little spaces at the ends of the fingers of the joint. It was the same work as all the other mallets, but it just didn't work out because I just didn't get it pushed together well enough. Made some little squares to go at the tailstock end of the mallet, which would be the head end. And I can glue those in the center. And this is just so I have a spot to put the tailstock on both the CNC and the lathe. And it means I don't have to use the precious wood in the head to sink the tailstock into. I can just use a scrap piece of wood. And I've got a little outline I can trace onto the blank. And this lets me just cut off the extra on the bandsaw. And once I do one side, I can glue one of the pieces back on again. Hot glue is good because it sets up super fast and it doesn't have to be that strong. I can follow that pattern to do the other side and I get a three-dimensional shape out of this. Then it's getting a little bit closer to the mallet shape. The ones I did early on this batch, I didn't have the rotary axis on the CNC quite working. So I did the first 5 or 7 of them, I did all on the lathe. And it's almost as fast doing it this way. But it is a lot of material to remove. It's interesting that parts of this shape, like the head and the kind of middle part of the handle, are super easy. Then other parts, like the ball at the bottom, which also isn't too hard, but the part I really spend the time and the care on is the transition between the handle and the head. Getting that shape just right so your hand kind of fits into that space and it looks right. If it's too fat, it doesn't look right. If it's too thin, it doesn't look right. It just has to have the right kind of sexy curve to it. When I was doing these a year ago, or I guess 2 years ago, when I had the 4th axis running, I kind of knew I should be rotating this as it cuts and having the bit sort of spiral from one end to the other end. What I could figure out was to have it go back and forth, which gave me a nice surface, and it looks cool in a time lapse. But it always felt like it was just wearing out my z-axis going up and down each time it goes back and forth. And I'm cutting these a little thick, they're a little big, so I have some material to take off on the lathe. Now, recently I figured out how to set up a spiral pass. I'm not sure if that's what it's called, but that's what I'll call it. So the rotary just rotates and the bit moves along the shape of the mallet. And it doesn't give me quite as nice a surface because I get these steps in the shape, but that's completely okay. I can turn those off on the lathe. And they're kind of cool when you see them moving on the lathe because it's a spiral. But it makes for a quicker cut on the CNC, and it just feels like the Z-axis isn't working so hard. Then I can turn these down. And it's nice doing it on the CNC as I can remove a lot of the material and get it so it can spin faster once I put it on the lathe. It's more balanced. And I can turn off sort of the final layer. So I'm not spending time just removing a bunch of material. I can spend time on the parts that matter, making the final shape. Like I was saying, the curve between the handle and the head, I always spent the time to really try and make that look right and feel right. And I did the end. Didn't have the CNC do the end at all. It just starts with a cylinder. It's not too hard to quickly shape this on the lathe. And I can get to the shape that I want. Then I can sand. I've come up with a process now where I use my grinder to start. And the grinder is really fast and has a lot of torque. So it really removes a lot of material. And if I'm not careful, it tears apart the sanding disc. So I do have to be kind of careful with it, especially around the edges. But this allows me to shape even a little more and get rid of the tool marks pretty quickly. Then once I'm done with the grinder, I can go to my drill sander. And this is a little lighter and more delicate. Then I just go through the different sanding grids. I think because the grinder spins so fast, I can step up in sandpaper quickly after the grinder. I think I was doing 80 and then 120, and then I could go right to 150 or even 220 with the drill sander. Once the main body of the mallet was done, I could cut the end off and then do the end. I've got a steady rest I made to hold the mallet while I work on the end. I can even shape the end with the grinder and then just sand the end. I keep the drive side intact until I'm done with the end of the head. Then I can cut off the connection piece I glue on the end of the blank. I'm going to save that. I made a set of wooden jaws for my chuck that will hold the head end of the mallet while I'm doing this. I can shape the handle end and then just go through the different sandpapers and smooth that end of the mallet. And this goes pretty quick. It almost takes longer mounting the mallet in the lathe than it does to make the final sanding pass on the mallet. Then I've got a clamp I made for the CNC at the end that'll hold the mallet so I can cut my initials in the end of the mallet. I can put some finish on. This was the finishing pass from 2 years ago. I've made a bunch more this year. I made a bunch with the airport flooring white oak material, and I made a few with some of the remnants of dunnage wood that I have and some more solid pieces. Some of those pieces were cracked here and there or had defects, so I played around with cutting out some of that stuff and kind of filling it in with some pieces from the white oak. There's some a little bit more fun mallets in this batch. I really like this one that kind of looks like an F on the end. I'm kind of wondering if I should do a FH segmented piece on the end. I think that'd be kind of fun. Thanks for watching.